So we've talked a little bit about the fact that your job doesn't end when your code simply works, but it may be hard for you to know where you go from there. You know you should do more, but you don't know what more even is. So what should you even be aiming for? That's what we're going to talk about. Working alongside developers who do have more experience than you and who can provide some mentorship helps. But let's dig into some specific goals that you can set for yourself. My friend Tony Dewan, who builds a lot of cool stuff and who teaches college web design courses from time to time, came up with a scale to measure the quality of a developer's work. In context, he provided this guide to his students to give them an idea of how their work would be graded. But I think it's also useful for professionals to gauge their own work and to realize where they have room for improvement. I've reworded parts of it just a tad. First, does it work? Does it meet the functional requirements? Remember, this is just the first point of the scale, and there's lots of empty space on there. Just getting something to work is the absolute minimum. In the context of Tony's class, it's probably enough to pass the class. At work, it may be enough to keep from getting fired. But if there are cutbacks, you also might be the first to go. I should be using the Seth technique and having people read this stuff. Hey, Alex, what's that say?
Does it work well?
Does it work well? Is the user experience acceptable? User experience, that just means beauty, right? Like, is it pretty, right? That's all user experience is? Is that right, Clayton? That's right. No. And Clayton knows that too. He's just funning you, son. In simple cases, it could mean something like making sure that when the page loads, the right form field is focused, right? The kind of stuff I've been harping on. It could mean that some process flows in a way that makes sense. In NoteHerder, we looked at some examples like when you create a new note, as soon as that thing is saved for the first time, the URL updates to be the URL that points directly to that note. That kind of stuff is all part of the user experience. And that, as far as I'm concerned, is part of working well. It could also mean making sure that the back button does what the user expects it to. When you're working with single page libraries like React, where it's kind of up to us to manage the history manually with things like history push and routes, we're going to have to kind of design that experience around when the URL changes and thus what the back button does. That's another part of making it work well, not just checking off the functional requirements. In the context of Tony's class, making it work well means you'll probably get a good grade. As a professional, you might start getting kudos from other teams, sales, marketing, maybe even end users. To relate back to our experience at InFrame, when we reached this point, people from other departments at InFrame, because remember, none of them were programmers, would start saying things to us about, like, thanks for doing this thing. We've been waiting for this feature forever. Now, on the other hand, your own teammates may still hate your guts if this is as far as you've gotten. Can it be made, I'm sorry, hey, can you read this, please? Yeah, you. Yes. Thanks. Can it be made better? In other words, can the code be refactored? Who knows what refactoring is? Who's heard of refactoring? Anybody? Yeah. Oh, okay. Okay, that's fine. I'm sorry. Refactoring is the process of restructuring existing code without changing its behavior. Refactoring improves non-functional attributes of the software. You haven't actually changed the way it works. You've just changed the code to be more maintainable, for example. Because remember, it's going to be read a lot more than it's written. And the future developer whose life you make harder may be a future version of you. So be nice to yourself and your coworkers. It's not enough for it to work. It's not even enough for it to work well. It needs to be written in such a way that if someone finds a way to improve it, it's possible to do so without making a huge mess of things. For example, refactoring code for which no tests have been written is, well, actually, according to the definition of refactoring in the book Refactoring from which it came, it's impossible because it's part of the definition. How can you be sure you haven't broken it or changed its functionality in some subtle way if you don't have tests for that? So that's part of this, can it be made better? Tony tells his students that if you reach this level, not only will you pass the class and probably get a good grade, you'll probably get a job. As a professional, I'd say you'll probably get promoted if you reach this stage. There's still room for improvement, though. Could it work elsewhere? I interpret this a couple of different ways. One is that you make your code self-contained with as few dependencies as possible, so that if you found another problem that might have the same solution, you could drop your existing code in with minimal changes. Components encourage this sort of design. If we're all one huge HTML file, one huge JavaScript file, it's a lot harder to take little pieces of that and reuse it somewhere else than if you write a bunch of self-contained components. Here's another way I read this. The ability to create generalized solutions that solve more than just the specific problem at hand is incredibly valuable. Say you've written something that presents data from a very specific API endpoint, like Mars rover pictures. What if you created a reusable component that could, with just a little configuration, present data from a variety of endpoints? Maybe you could even create an NPM package out of it, so anyone can use it. Stuff like React RTE that we looked at yesterday, the rich text editor, that's because someone solved that problem, and they didn't just solve it so that it fit their exact use case in their app. They made a general purpose solution and shared it with others because they weren't the last people in the world who were going to need a rich text editor that outputted HTML. The author of Rebase. There were already Firebase packages that you can totally use, but he had he wanted to make it a little easier, so he wrote something that made it automatically sync with a component state. But he wrote it in such a way that he could take that and do it in another app. It wasn't tied to the specific needs of the app for which he first wrote it. So he made an NPM package out of it so that we can benefit from that. Those are just mere mortals, and it probably wasn't their job to make Rebase and their job to make React RTE. It was probably their job to write a thing for which Firebase syncing would be pretty handy. So they created that general purpose solution, and they published it. Back at InFrame once again, once upon a time, someone came to us with a requirement where they needed to be able to generate PDFs from this ticket system. So, Miles and I talked about it, and we decided that we should use something that converts HTML and CSS to PDFs, because we saw something that does that. And Miles said, ooh, I'll write a reusable package, kind of like an NPM package, but in the case of Ruby, those are called Ruby gems. So he's like, I'm going to write this as a gem. So he wrote a gem that takes HTML and CSS in and outputs PDFs. Well, guess what? He wasn't the only person in the world who wanted to do that. So he published that, put it up on Ruby gems, put it up on GitHub, and now thousands and thousands of people use that. And sometimes we'll even have clients who hire us for mentoring stuff. We had a really big client, not big in terms of like how much they paid us, but in terms of like how big an organization it is. They weren't even local. And like one of the first days we were helping them, they're like, hey, do you know anything about Wicked PDF? I'm like, what a coincidence. The guy who maintains it is sitting in the back of the room, Dave Jones. So I popped into the chat room and was like, hey, Dave, somebody's got a Wicked PDF question. 3 million downloads. Gosh dang, man. Let's hear it for Miles and Dave. Wicked PDF. So they've reached stage 4 of the scale of awesomeness. Tony tells his students that if they reach this level, they'll get a job, probably the best job. Now, this originally was the end of the scale, but you'll notice there's still some more space underneath that. And that's just really just because Tony thought of these things later. The truth is this one is probably the last stage of the scale of awesomeness. These other things probably belong just above that. And really, they sort of just expand on the can it be made better thing, because it has to do with the quality of your code. Can anyone else understand it? I'm sorry. Hey, Jason, can you read that for me? Thank you. Got to keep people engaged. When you're working on a team, it's not enough to make stuff that works and works well. Other people need to be able to read your code and understand it. Even code that solves complex problems can be written in a readable way, and it's really important. Sometimes that just means making sure that your methods really only accomplish one job. If a method's getting to be 20 lines long, it's probably doing too darn much, and there's probably stuff that we could extract out of there and make other smaller functions out of. And make sure your functions have good names that describe what it's actually doing. That can save you from having to add a bunch of comments because, well, you can just tell from the name of the thing what it actually does. We did this yesterday when we were looking at note herder, right? There was an if statement, and we were checking whether some ID was there, but what we really wanted to know was whether this note had been saved before. So we wrote a little method. All it did was return this Boolean, but we named the method existing note or something like that so that it was a little easier to understand why that line of code was even there. Stuff like that. Can anyone else understand it? And remember, you have to be able to read your own code later too. Can anyone else understand it? Yeah, sorry.
Do you have any tips on commenting code? Because, I mean, I don't like doing it, and we didn't do it in the boot camp, but I know it's generally good practice.
Boy, this was a cause of great controversy last year. Personally, I see an awful lot of code with no comments, and I'm perfectly happy with it because they followed the advice that I just gave. They keep their methods really short, and they name things in a sensible way. By giving your methods one responsibility, giving each of your classes or components one responsibility, and naming them something that describes what they represent or what they do, sometimes it's not necessary. And then from time to time, you'll do something kind of complex that maybe demands a comment. Or where, yeah, maybe you can figure out what it does, but you can't figure out why the heck it does it. So in circumstances like that, you might comment. Right. Yeah. Another thing that really aids with documentation and sometimes can save you from comments are your git commit messages. Make those things good and make your commits small. So someone reading over that, they know what your code does because it's right there in the commit message or the pull request. Dave, do you have anything else to say about commenting? It's a thing you talk about sometimes.
Yeah. So a lot of times I'll start out with some code and just like write out what I want it to do. Those will be in comments, and then I can replace the comments with the code that implements what needs in. And if you name it, well, sometimes you can name it almost the same as your comment if you're curious about it. I guess it doesn't matter, but if that helps you work, like that's great. But like if you're just adding line noise or if you're just putting a label on something, like you already have a method or a function that's your label. If it's doing something really complex in the middle, maybe you can break out and explain it more. Sometimes you can't. Maybe sometimes like this is just Fibonacci algorithm 7. But there are other ways to use comments that can be helpful. Like I got the idea to use this from this Stack Overflow. Sometimes I'll put a Stack Overflow link in something if you're using something weird, like front-end library. A lot of times it's good to go why you went with this one. Sometimes a little note about a business case or just a tricky thing like Seth was saying, like this works as you would expect on whatever, but now I have to do something dumb on Android just because, right?
Because Android is dumb, is what he's saying.
so clear you don't need it. So you want to make the code so clearly.
That basically it can't be misunderstood.
Constraints of time though, like we need to throw a hack in there. Maybe that's the time to put in the comments.
And another advantage of breaking things into little small methods and just writing code the way that we're describing is it often forces you to think harder about how you design your solutions, and you end up with code that just plain works better too. And you catch some of those edge cases earlier. Thank you for that, Dave. Sorry, people listening to the recording and who didn't hear any of that wonderful advice. Yeah, to his point about Stack Overflow and stuff like that, like sometimes I would put a comment that points to a particular blog post that somebody wrote that explains why we're doing something. That's another good example. An example that I would say is a silly use of a comment is right above a method signature. You have a comment that says the name of the method and the name of its arguments. Well, that is the method signature. That's literally what a method signature is. That probably isn't necessary to say that it's named this and it takes arguments named this. That is exactly what the next line of code says. So anyway, but it is an important point. Do as the others on your team do. If you join a team and they have a house style already, and it's established that they do their comments in a very specific format, maybe because they have something that automatically generates documentation based on the format of the comments. Don't like start a fight with them over that and say, well, Dave Jones and Dave Struth said comments are lame. That's conform to the style guide of the team you're on. Can anyone else understand it? Everyone else? Will it work in a year? In 5 years? It's impossible to make your code completely future-proof, obviously. But you can do a lot to ensure that it keeps running over time and that it doesn't break the day after you write it. For example, make sure to specify the version numbers of your dependencies so that when you encounter something like the rebase upgrade last week, your code keeps working. Case in point, Note Herder still works despite using the previous version of rebase, and it'll still work if you clone it and run npm install. You'll need to have your own base.js file because I didn't commit mine, but it won't break just because rebase got updated. On the other hand, don't use deprecated APIs when possible. Sometimes when you're compiling, or even sometimes in the console in the browser, you'll see deprecation warnings telling you that this is no longer the way to do this thing, so switch to this other style. And you can bet in the next major release, that way isn't even going to work. So get in the habit of using the new way. So Note Herder, since we didn't rebuild it from scratch, we just kept it working with the old version of rebase. But Thing List, since we were rewriting it anyway, we went ahead and updated it to the new API. Because we know, someday down the road, like Firebase is going to get an upgrade, and rebase is going to need to be updated to support that change. And guess what? They're not going to go update the old version of rebase. So sooner or later, it'll break if you use the old stuff. So when you have a choice, use stuff that's up to date. So the point of the scale is to keep growing. Don't just stop as soon as you hit the minimum requirements. You won't learn as much that way. You won't grow. And yeah, that may have actual financial consequences because you don't get jobs that are as good. But also, you just won't feel as good about yourself because you all care about quality, right? You want to have pride in your work. That's right. So I'll pause for a moment here before we get into some other details about what it means to be a senior developer. Everything we've been talking about is really within the sphere of technical capability and kind of how you measure how much you've progressed in the realm of being able to produce good code. But there's more to being a good employee and a good developer than being able to write stuff that works, is reusable, can be read by others, etc.